So, generally, just a few introductory words. What we are doing with when we classify horses or conformation of horses, what we are interested in later is how do the judges agree? What's the agreement between each other? And we have several questions. What's the agreement between the judges, and also what's the experience of a good judge? And the third question is, are there personal attitudes who influence the outcome of the judging? So these three questions we will focus throughout the talk, and I will also try to show you then how the outcomes have been in the last 3 years during the judging clinics. What you see here on this slide is the outcome of an experiment with the Lippis and stud farm directors. We also made experiments with the directors, and here you see the rankings, the best ranked Lipizzaner stallions from the stud farm of Biber in Vienna. So first place was Maestoso Bona, second Neapolitano Madeira, third place Neapolitano Biserca. And we were using a classical conformation scoring system, and the animals are ranked here according to their total score. So that's what you see here. When we break down the total score to a distribution, we see that we have more than 50% in combination which we would call a class like 2A. Then we have a better class 1B, we just have 4% about, and the second majority will be found in a third class 2B, which is a little bit less. So you can see how this classification or the categories are built by the total score. We can break them down on a finer scale, and then we see a much better distribution, which is also coming near to a normal distribution. But what we have to consider on the right lower corner, we see also that in the class and in the category 2A, we have also a bunch of 40% of horses being there. This we will discuss then later on. Same experiments with stud farm directors in the stud farm of Biber. You see the best ranked mares according to the total score. So the first place goes to Musica, second to Amena, third place to Bionda, and so on. Going back to the distribution of scores and to the distribution of scores in categories, we see a much broader distribution in judgments concerning mares. So we have no best classified mare in 1B, but we have nearly normal distribution in 2A, 2B, and 3A. What we see here, we have the scores were much smaller than in stallions. So the stud farm directors were judging more severe on mares, and on stallions they were a little bit easier going. So this we can see now. What we also see in the illustration down on the right corner is we have pretty good proportion between the categories when we see this. So they're equally distributed, and let's say we have differences. So, to the conclusions, I just was talking, mares have been judged more severe than stallions. That's one of the outcomes we see. We have here the distributions for stallions. We have 4 horses in category 1. So much more horses in the best categories and less horses in the worst categories. And you also see it in the total score. Mean score for mares was 7.27, and the mean score for the stallions was 7.54. On the other hand, we see that the mares, although they have lower scores, they have been judged more differentiatedly. So the stud farm directors were much more differentiated in their judgments. Okay. Another step. When we go to the original scores or to the single scores, we can transform them to the rankings or placings, like the first, second, third, fourth, and so on. You have seen the picture here. The horses were ranked according to their total score. First place goes on Musica, then Bionda and Mena. Averaged overall 6 raters. So that's the way in a breeding program, the ranking, the outcome of a selection procedure is built. When we go to the single rankings of stud farm directors, we see not all did agree in their perception of the horses. So we see in horse number 1, rater 1 saw Musica on the 13th place, and rater 4 or rater 5 saw this mare on the 2nd place. When we go to Toscana, we see that nearly all raters saw this mare in the 1st or 2nd place. So we have they were ranking this mare very high, just except one rater who didn't like the horse and was rating it on place 33. Similar we see in the mare Trompetta. We have, let's say, 2 classes of judges. One class is seeing this horse on the 1st places, and another class of judges seeing the horse on the 10th place, so in a much lower category. So that's reality, more or less. What we always experience in working with horse classifications when we have selection procedures, we always involve more classifiers at the same time, and then we get such pictures. And the more agreement we find, so the less differences between rankings, desto more stable the judgment on the horse is. The higher the agreement, the better the estimate of the phenotypic value of the animal. What we see from the whole distribution here down, we have just a distribution of differences between judges. We see that on the edges, on the positive edge or on the negative edge, the differences are smallest. So judges know good horses and know bad horses or negative ideal horses. So these edges are well defined. And the most or the main difference between judges we see in the middle field. And here we have lots of difference in approaches how to judge a horse, or also in visualization processes between judges. And what we do, or what I want to present you now, is just a set of some statistical methods how to evaluate such data or such outcome of judging protocols. So, and the simple statistic is a correlation coefficient or a kappa coefficient. It's just the coefficients between 0 and 100, and telling you how high the agreement between judges is. So correlation of 1 says, okay, rater A and rater B have complete identical outcomes, and the lower the correlation or the coefficient goes, the more differences between raters exist. So we can measure it very simple. And here you have the table for the coefficients concerning these experiments with our stud farm directors. And we see here, expressed with a kappa value, we see that's around 40 to 30%. So it's not very high, but it's okay. When we talk, the correlation is a little bit higher. We vary between 30 to 70%, and this is the same we see in literature, where we also have the same distribution. Lift Clinics 2013 in Lipica. This was the first clinic course in the last decade we were organizing, I think, for learning lift members or training lift members how to judge a horse, and we did this in Lipica. And we had 20 horses about, and we had about 15 students taking part in these clinics. So we have, concerning our coefficients, we see that the teachers, I think we were 3 or 2, had an agreement of 0.25 on average. Students had an agreement of 0.03. So there were lots of difference within the students regarding in the visualization process of equine conformation. Giacomo 2016, this was this year. We had, now I have correlation values, but in the second table we see the kappa coefficients. We have in Jacobo reached a value of 12% for all. For directors, we reached a value of 15%, and for students, we reached a value of 11%. And when we look at the development from 2014, 2015, 2016, we see a constant increase by 2 points. So it's growing. The agreement between the students is growing. Agreement also between the teachers or trainers is growing. So it's a constant learning process which we can read out of our data. And that's just an illustration for correlation matrix or correlation coefficients for the scoring data we are all producing in Jacobo in the clinics. And for visualization purpose, I just put 2 circles. The red circle is representing ratings or students who were correlated more, who had a higher agreement, let's say. And the agreement in this circle is ranging between 40 to 60%. So that's a value we find in literature. That's a value that covers the same outcomes. On the left side, we see students which are more far away from this first group. The agreement is less. They have different ideas. They have different scales, maybe. So that's what we try to work out in these clinics, just to get nearer, to get a higher agreement, to get a more distinctive way of looking at the things. We also see in the circles that some points are marked. Red was our teacher, Jannes, who gave the direction where to go. We need such guys who give us the direction, because we need some orientation in horse judging what we want. Blue are stud farm directors we see in these circles, and gray are, let's say, stud farm associated people who work in a stud farm and are used to score lots of horse throughout the years. And we see this here. We have this group of experienced Lipizan classifiers, and on the left hand we have much more variability in ratings. We also can break down such a correlation matrix on nationality, because in Lipizan breed we have several stud farms and we have several opinions how to breed a horse, or several opinions about breeding objectives in different countries. And so we see here in the center Austria and Slovenia, on the right side Hungary, on the bottom down, and on the left upper corner we see also our Swedish colleagues who have their own ideas about the Lipizan breed. And that was just the same illustration from the LIV clinics of 2015 in Topolčanky. We had 2 different groups. One group was with me and one group was with Jannes. And so we see in the correlation matrix we can reproduce that we did lead the students slightly different, because we all see horses individually, more or less. That we also can recalculate by using scoring data and analyze it. Some things we are working now in our bridge project since some years is to put something to the score, some information to the scores, to put phenotypic information to the scores. And so with these new methods, we're taking an approach of image analysis. We try to expand such a statistical analysis of ratings, let's say. And the major thing what we do, we take out phenotypic information from image data, standardized image data, and try to correlate this data somehow with statistical, with this scoring information which is coming from the classifiers. So here in this illustration we see 2 different stallions on the left side. Then we can take out this phenotypic data from the images. We can statistically analyze such a data. We can create mean horses out of this data. We can also illustrate this mean shape of a Lipizan horse with such a data, and we then can also recalculate the images or the horses based on this new calculated mean. So what we see here, horse number B is an original photograph, and the big photograph is the same horse just calculated for this mean configuration, which comes out of a sample of 100 measured Lipizan horses. And that's the same horse just scaled on the mean shape. Same we can do here for the horse with number A. So this we call model horses or ideal horses or negative ideals of horses, these big new calculated shapes. And we also can make mean photographs, so we can create new or calculated new shapes according to the protocols we get from classifiers. This technique is more or less has been taken from a big field of research in the last 10 years, which is concerned with studying attractivity in human and the reasons behind. So we expanded this methodology and made similar experiments within Lipizan breed, and also within, not only within the horses, but also within the flock of Lipizan horse classifiers. So, what we see here is rankings of stud farm directors for the character or for the trait breed type, which we did for stallions in the Spanish riding school. We have a negative RDL on the left side, according to our judges, and we have a positive defined ideal according to our judges on the right side. And in the middle we have mean value or the mean shape of the horse. Mean shape of the horse is looking like this. It has a score of 7.92. That's the mean of the total score in the 100 stallions of the Spanish riding school is positive. Ideal horse in Vienna would look like this and having a score of 10, total score of 10. And the horse would look like this. This we can calculate out of all the data, phenotypic data and scoring data. And the negative ideal of a Lipizan horse in the Spanish riding school would look like this, according to the scores of the judges. If we change the judges, we would generate other model horses. So that's directly correlated, this information always. Another question, and now we are coming nearly to the end of my talk, is personal attitudes of raters, of classifiers. We know we are born in a specific country, we all talk different languages, and we all grew up in different cultural societies with different attitudes. And concerning horse breeding, we grow up in a certain specific environment where the specific types of horses are favored or specific breeds are kept and so on. And these attitudes also are manifest in our ratings when we see horses. We are not subject and we are not objective. We are just bound. We are more or less the product of our environment in such a case. And how do personal attitudes affect judgments? That was the second question or the third question we did. And we try to analyze, and here I have 3 model horses on the negative edge, on the negative scales, from 3 different raters. So the images were calculated according to 3 different raters. It's always the same image, it's always the same horse, but just visualized according to the scoring protocol of 3 different raters. I will show you if we change to the positive ideal horse, it's changing all like this. And when we go back, now you just concentrate on rater number 9, that's the horse in the upper corner. Going to the positive ideal and then back going to the negative ideal. What do we see in the negative ideal? We see a pretty long horse, middle, with a weak back, then the croup is pretty short in this case, and neck is also a little bit short in comparison to the length of the horse. So that's this negative ideal of rater 9. Positive ideal is a compact quadratic horse type with a deep chest, with a well-developed backhand, with a long croup, let's say, with a pretty long shoulder and strong neck. When we look at the profile, this we don't see very much. We see also that this horse has a slightly convex aerobic profile, but just very, very small. We can see it on the resolution here. So, what did we learn from analyzing all the data, analyzing outcomes of our clinics in Lipica? We see that the measure of agreement, the coefficient is slowly, slightly growing from clinics to clinics, so we can improve our agreement between judges. And this is an essential thing when scoring the horses. Inter-rater correlation generally is on a medium level. We would like to have a higher level between our judges, but this can just be changed by training. And with this outcome, I want to end my talk and thank you for being here, thank you for your attention.